Hi, everyone. I know that there are still people joining, but I like to just go ahead and make a quick introduction since it's 11 and we want to use all of our time today. So I'm Nicole Scott. I am the project manager for the Agricultural Genome to Phenome Initiative, which is also called AG2PI. So thank you today for joining us. And hopefully you're able to join us last week as well for the first of this three-part series on Introduction to Scientific Computing. So if you're able to join us last week, you'll recall that we discussed Python and Jupyter notebooks using the Google Colab. If you were not able to join us, there is a recording available on the ag2pi.org website. So feel free to go back and check that out. We are also recording today. So if you're not able to join for the entire time, or if you have friends that might want to see this, you will find a recording soon after the conclusion of the event on our website. So today our speakers will be discussing shell scripts, data analysis and discovery, and machine learning using Python packages. We have the same presenters as last week, Arian, Travis, Manuel, and Nathan. They're all joining us through the University of Arizona. And they are undergraduates, graduate students, and postdocs. We really appreciate them lending their expertise and time as the end of the spring semester draws near. So I will pass it off to Emmanuel to get things kicked off. Thanks.
Thank you, Nicole. Before I get started, can everyone see my screen and hear me okay? Give me a thumbs up. Awesome. All right, so today, as Nicole mentioned, we will be continuing our introduction to scientific computing. So my name is Emmanuel Gonzalez. I am a PhD student here at the University of Arizona in Dr. Duke Pauli's lab. So session 1 focused on Python and Jupyter notebooks, and for the purposes of today, we'll be going into shell scripts, data analysis, and machine learning. Next week, we will be conducting our third session in which we will discuss version control using GitHub. So we hope that you can join us for that third session. And as Nicole mentioned, please do take a look at this Python and Jupyter notebooks workshop that we gave just last week. So I'd like to start off with a brief history of computing. So the precursors to computers were way back. This started off with the abacus, and then eventually it evolved into the arithmometer. Now, you might be wondering, what were these used for? Well, these precursors to computers were mostly used for mathematical operations or calculations, vastly different from what we use computers for today. So let's take a look at something that looks a little bit more like the computers that we know of today. So in the 1940s, computers looked something like what you're looking at here at the top left of my screen. Very different, and a lot of human interaction. Again, these were generated to do many more mathematical operations than what the abacus or the arithmometer was capable of doing. Fast forward to the 1960s, and we had the development of the mouse. So this was the very first mouse ever developed. And as you can see, it looks very different. It's made out of wood, not plastic, and it only had a single button, which was red. So you might be wondering, wow, that looks very different. Did people use it? And the answer to that is not very many people used it. It took a while for it to actually catch on. So that's evident here in the 1980s. You can see this computer, it had a screen, a keyboard, but what's missing here is a mouse, right? So most of the interactions that happened with this system were primarily with the keyboard. Now taking a look at the 2000s, and we have the Mac G3. You guys might be familiar with this. If you are, give me a thumbs up. I definitely remember these being in the public library, and these were really one of the first computers that I ever interacted with. Now let's fast forward to today, 2020s. And here we see something vastly different from the G3. This is no longer a computer that you have to sit on your desk with. This is a mobile computer that you can either sit on a desk and interact with, or you can take it with you as you travel. these are super thin machines. And as we can see here, this looks vastly different from what we saw in the 1940s. And this is only a matter of a few years in which computers have really evolved to what they are today. Now, what I don't have pictured here is the evolution of a completely different device, for example, tablets and phones, right? That's important to note because today, most tablets and phones are essentially as powerful as computers. Now, going through the evolution of computing is interesting, and that brought up one point. So I mentioned the mouse, and that mouse wasn't necessarily used very often until a few years later after its development. So what we see here are two very different ways of interacting with the computer. So we have our graphical user interface in which you are using a mouse to do your interacting with the machine. We have something known as the command line interface. So this is very similar to what we saw with the machine from the 1960s, in which there was no mouse and your only interaction was with the keyboard. So in this command line interface, you really communicate and move things around using text rather than using your mouse. Now, an example of that is here. So on the left-hand side, you can see a file explorer. This would be a graphical user interface in which you see your files and you can move your files, you can delete files. And on the right-hand side of my screen here, you're looking at a terminal or the command line. Here, we can see the same files. So for example, we see automation being our directory. And then we see all the files. We see a citation.cff. You can see that here. So these are two very vastly different interactions with computers, but we're still accessing the same file system, regardless of which one we are using. So you might be wondering, well, isn't the command line interface outdated? And the answer to that is not really. It might seem a little bit outdated, communicating with a computer via text, but this does allow you to automate tasks. So for example, here, I have an example of some of the research that I do. Oftentimes I have to run a command. I'm then interested in bundling the outputs of that command and then moving the outputs to a slightly different location. So as you might imagine, if we were to do this by hand and we had different pieces of data that we needed to process, we would have to sit down and run the command for the first data, wait till that finishes, and then run it for the second one, so on and so forth. And that wait time can be anywhere from 1 to many, many hours, right? So automating this via the command line is really useful. And that can be seen here. So if we have many tasks, we could just run that same shell script once over and over and over in iteration. So just as a reminder, today we are covering shell scripts, data analysis, and machine learning. Next week, we will be covering version control. So with that, I am going to get us started in terms of access to our command lines. So can everyone see my screen here? Give me a thumbs up if you can. Perfect. Okay, so within the chat here, I am going to post the link to this GitHub repo. All right. So I'll give you guys a few minutes to click on that link and bring this web page up. So once you have this up on your browser, go ahead and give me another thumbs up, letting me know that we're ready to proceed. Perfect. All right, so out of curiosity, how many of you are using Mac OS? So if you are using Mac OS, go ahead and give me a thumbs up. Okay, we have a few. All right. I'll have to wait for those thumbs up to leave. Okay, and then now, how many of you guys are using Windows? So give me a thumbs up. Okay, so it seems like there's a pretty even spread between Mac OS and Windows. So for the purposes of today, as you might imagine, different operating systems are very different in the way that we interact with them. And we will be using a Linux terminal. Now, for those of you that are on Windows, there is something known as the Windows subsystem for Linux, which we will be installing in just a few seconds. And for those of you that are using Mac OS or Linux, you are ready to go. So these next few steps that we will be going over, you can just listen in on and keep this in mind just in case if you ever do have to develop in a Windows environment. But just as a reminder, Mac OS and Linux users, just go ahead and open up your terminals on your machine. So you would want to search within your start menus and type in terminal. Click on your terminal, and that should bring up the terminal that we will be using for the rest of this workshop. Okay. So for those of you that are using Windows, let's go ahead and scroll down to the first section named Terminal under the Windows User section. Okay. So once we're here, we see an explanation as to how to install what I referred to earlier, the Windows subsystem for Linux. So in order to run this command, we need to open up our command prompt. So let's open up our start menus and type in command prompt. And here, what we want to do is run this as administrator. Okay, so let's go ahead and click there. And I'll leave this up for just a few seconds if you guys need to refer to it. This will work regardless of whether you're on Windows 8, Windows 10 or 11. Okay, so let's go ahead and open up our command prompt as an administrator. And your screen will go dark and it'll say, do you want to allow this app to make changes to your device? Let's click on yes. And then what you'll see is your command prompt open up in just a few seconds here. And that should look something like this here. So for our Windows users, once you are able to open up your command prompt, give me a thumbs up, letting me know that you are ready to proceed. I see a few thumbs up. I'll wait just a few more seconds until I see some more. Perfect. All right, so it seems like that's the majority of us there. So what we're gonna do now, I'm gonna go ahead and split my screens here. We are going to copy this command here for the WSL installation. And we're gonna paste that into our command prompt here. Now, I won't run this because I already have WSL installed, but go ahead and copy that in, press enter, and you should see your machine installing the Windows subsystem for Linux. So I'll pause here and let you guys run that command and give me a thumbs up if you see some output to your terminal. And if you're running into any problems, go ahead and raise your hand and we will have one of our colleagues here send you to a breakout room in which we can help you figure out those problems. Perfect, I see a lot of thumbs up, so it seems like we are all doing well thus far. So it will take a while to install. So what's happening on the back end is we are installing this subsystem. And what this subsystem does is essentially allows us to run a Linux environment within our Linux machine. Now, what's also happening is as it's installing that subsystem and getting all your file systems ready to go, it is also going to automatically install the Ubuntu Linux distribution. Now, some of you guys may have heard of the Ubuntu Linux distribution. This is one of the most commonly used Linux distributions out there. It is quite user-friendly. So that's what we will be using today. So whenever you see your download complete, just give me a thumbs up, letting me know that you are ready to go. Seems like a few of us are good to go, but the majority are still waiting, so we'll give it a bit more time.
Somebody's getting an error in the chat.
Let me bring that up. Yeah, so the requested operation requires elevation. Make sure that when you do click on command prompt, you launch it as run as administrator. Okay, so make sure you right click it, run as administrator, and that's going to give you the elevated permissions to run the command. So go ahead and give that a try. And if you're still running into problems, go ahead and raise your hand and we'll have one of our colleagues here assist you with that.
Aaron, would you mind joining the support room for a person who has a question that I'm not sure how to answer?
Sure.
Okay, so just to get an understanding of where we are, give me a thumbs up if you are ready to go and your command completed successfully.
Somebody in the chat is asking about whether or not they need to reboot. It looks like they got a message.
Yeah, so we should be okay proceeding. So just go ahead and once that finishes, close your terminal out. So we would just exit out of that. And then we would proceed with the next few steps. So it seems like we do have quite a few thumbs up. So I will now move on to that next step. So once we have the Windows subsystem for Linux installed on our machines, if we open up our start menus, we will see, if we search for it, in Ubuntu application. So you'll see Ubuntu on Windows. Okay, so let's go ahead and click there. And what will come up is this terminal here. So again, I'll pause for a few minutes, let everyone access that. So once more, you go to your start menu. And in the search, you will type in Ubuntu. You'll see Ubuntu on Windows, and this might be named slightly different depending on your machine, but it will say Ubuntu. You would click on that, and that's going to bring up a terminal. So if you successfully brought up this terminal, it will then ask you for a username. So this is the first time that Ubuntu is being installed on your machine. Go ahead and type in a username for your Linux machine. And then it will also ask you for a password. Also go ahead and type in a password. It will ask you to confirm that password. And then once you've submitted your username and your password, you should see something similar to what I'm seeing here on my screen. So I'll pause here for a few minutes. And as you guys successfully complete those operations, go ahead and give me a thumbs up. So I do see the question in the chat. So when I search Ubuntu, I do not have nothing. So what may be happening there is either the command did not finish successfully, or you may have to reboot. So if you can raise your hand, we will have someone send you over to the breakout room for further help.
Did you see Arian's message about sharing the screens in the breakout room?
No, I did not.
He says he does not have the option to enable it. I don't know
Give
if
me
you
one
can
second
help
here.
or AG2PI can.
And to see where we are, have people been able to successfully set up their username and password? Go ahead and give me a thumbs up if that is the case. Again, if you're running into any problems, go ahead and raise your hand, and we will send you over to a breakout room. So I do see at least a few thumbs up. So we will just give it a few minutes until the people who are in those breakout rooms are able to get their WSL systems installed. So as we wait, we will take a look at the room here and just have a quick discussion. So how many of you guys have used Linux before? Those of you that are installing the Windows subsystem for Linux, have you ever used Windows before? I see a few thumbs up. Awesome. Had you guys ever heard of the Windows subsystem for Linux? And feel free to unmute yourselves or go ahead and fill that in the chat.
Hey, Emmanuel, it seems like folks are still not able to share their screens in the breakout room. Do you have any idea how we can get that taken care of?
Give me one second here. So we would have to contact AG2PI support. So if they can enable that screen sharing, Arian is a co-host. So is it Arian that isn't able to share his screen or the participants?
The participants.
Okay. Okay, can you have him try now?
I don't see him responding to my message, so I'm going to join the breakout room real quick and I'll let you know.
Awesome. Okay, and as we wait for those breakout rooms to finish, out of curiosity, in the chat, just go ahead and write in what your research is. What type of research do you do? How are you using computing? Are you not using computing? Just so that we all kind of know what where we are in terms of this computational toolkit. Bioinformatics, awesome. Analysis of genomic data, animal science. Yeah, so there's quite a bit of spread in terms of between bioinformatics, animal sciences.
The participants are able to screen share in breakout rooms, so appreciate you getting that handled. Thank you.
Awesome. You're welcome. Non-covalent interactions between PT complexes and a bunch of biomolecules. Nice. Plant breeding. Awesome. So yeah, so as Nicole mentioned at the beginning, we are a group of graduate students, postdocs, and undergraduate students. We work within image processing and also point cloud data processing. So it's interesting to see the spread here between people working in the animal, other people working in the chemical sciences, others in plant sciences. So, so it seems like a few people are joining us back from the breakout rooms. A lot of you within genomics. Okay, so just as a reminder, as we wait for those breakout rooms, I'm going to remind macOS and existing Linux users to go ahead and open up your terminals. If you are on either of these systems, you would just have to search your applications for terminal. Go ahead and open that up, and you will see something very similar to what I'm seeing here on my screen. So that way, once those breakout rooms make it back to the main room, we can continue. And if you are experiencing any problems as a macOS or Linux user, go ahead and let us know. Okay, so if you are a Mac OS or Linux user, were you able to successfully open up your terminal? Go ahead and give me a thumbs up just to make sure we are all good to go. Perfect. Awesome. Okay, so as we wait for those breakout rooms to make it back to the main room, we are going to take a brief break. So let's go ahead and take a 5-minute stretch break. Go ahead and refill your coffee cups. take a bio break, and we will be back in 5 minutes. So let's meet back here at 9:36 Arizona time, or 11:36. Okay, so we've just had a 5-minute break. So if you are back with us, go ahead and give me a thumbs up. All right, it seems like the majority of us are back. So we're going to go ahead and proceed with the next few steps that we have here in this workshop preparation section. So we've just either installed the Windows subsystem for Linux, or we have our Linux OS or Mac OS terminals up and ready to go. So that's the first step. One of the other things that we're going to be doing today is also using something known as an IDE. So how many of you guys have heard of the term IDE? Seems like not many. So an IDE is an integrated development environment. So for the purposes of this workshop, we are going to be installing VS Code. So VS Code is an IDE that allows you to edit Python scripts, also develop and run Jupyter notebooks. So our previous workshop, we ran our notebook within a Google Collaboratory notebook. This gives us an isolated and removed computing environment from our own. So that Jupyter notebook is actually not running on our computer, but it's running on some Google virtual machine. So for today, we're going to be transitioning from that Google Collaboratory to our local machines. And then furthermore, we're going to be taking Jupyter notebooks and generating Python scripts from those notebooks. Okay. So let's go ahead and get VS Code installed. So if you are on Mac OS or a Linux user, go ahead and click here. And for those of you that are running Windows and the Windows subsystem for Linux, we would click here. So let's go ahead and click there, and I'll walk you guys through. So here we'll have the download page. Let's go ahead and download the environment that corresponds to your to your computer operating system. So if you are on Windows, go ahead and click here, Linux, and Mac OS. So I see a question, can we use Anaconda instead of Jupyter? So we will be installing Conda, and we will be using it throughout the workshop. So yes, if you have a different IDE that you prefer, feel free to download whichever you prefer. So I see another question here. For Mac OS, just go ahead and click here under this button here. Just click there, and that will actually download the executable file for Mac OS. Okay, so I will give everyone a few minutes to download those files and run them, get the VS Code IDE installed on your machine. So I'll take a break here. And if you do have any questions or you run into any problems, go ahead and raise your hand and we can address those problems. So I see clicking on your screen does not download for Mac for me. So you're gonna have to go ahead and actually click the link here on your own machine. And that will take you to this web page. Once you are here, we would then download the installation file for whichever operating system you are using. So once again, go ahead and scroll down to section number 2 under VS Code. You'll see the corresponding operating systems. Whichever one you are using, go ahead and click on Install VS Code. It will take you to this page here, and just go ahead and download whichever one corresponds to your operating system. And once you get VS Code or whichever IDE you prefer installed, go ahead and type in the chat installed. That way I know how many of us are ready to go. Thank you so much. And I see a question right now. We want to work with Ubuntu. So if you are on Windows and you just installed the Windows subsystem for Linux, we are still going to click on Windows. Okay, so when we do that, we will have VS Code installed not only on our Windows machine, but we will then do a second step that will allow us to connect that VS Code to our Windows subsystem for Linux. So if you are a WSL user, go ahead and click on this Windows download. Okay. Okay, I see many of us having successfully installed VS Code. Okay, so we are going to proceed with the next few steps. If for whatever reason you are running into problems, go ahead and raise your hand. We will send you over to a breakout room for further help, okay? So for people that are using Windows and now have installed the Windows subsystem for Linux, there is one additional step. After you install VS Code, we are then going to install the remote WSL extension by clicking here. So I'll do that, and we will come to a window that looks like this. We're going to want to then click on this green install button here. And that will then install the remote WSL extension within our VS Code installation, okay? So I'll go ahead and post this link into the chat just in case you guys need it. But that's also contained within the README here. Okay. So once more, we are going to click on this link here if you are running Windows or Windows Subsystem for Linux 2. We're going to click on this green install button. And then we're going to see a screen like this that asks us, or that tells us that the Visual Studio Code application is required. We just installed that, so go ahead and click on Continue. And this will then open up your VS Code, install this extension, and then we'll be ready to go. So for those using the Windows subsystem for Linux and who have followed these remote WSL steps, if you successfully completed that step, go ahead and give me a thumbs up. Okay, we'll give it a few more minutes. I see a couple of thumbs up. Let's just wait a bit more just to make sure we are not proceeding too quickly. See a few more thumbs up. All right, and Nathan just sent a reminder. If we do move too quickly, you can follow along using our GitHub README. So he just shared the link with you guys. I shared it with you guys at the very beginning as well. And you can follow along these steps that you see here on my screen, okay? So there's a question, can you share the code to install VS code. So there is no code. We would just click on this install VS Code here. Okay, depending on your operating system, that will then take us to a page that looks like this. You're going to then click on whichever operating system corresponds to yours and continue with the installation. If you don't have the link to this README, Nathan just posted it. So go ahead and click there if you do need to bring this README back up. All right, so one last time, for those of you using WSL, if you were able to successfully download this extension, give me a thumbs up. I see some new people with thumbs up. So let's go ahead now and continue with our workshop. Okay, so now we have successfully installed VS Code. We have our terminal, so we are ready to go. We now have a computing environment in which we can connect to an HPC system at your university, write Python scripts, write Jupyter notebooks. And it's this computing environment that will be helpful within your research. So let's go ahead now and follow along with the last section here, which is going to finish installing some preparation scripts for your computing environment. Okay, so let's scroll down here to the bottom of this README under section number 3. So I'll give everyone a few seconds to scroll down here. Okay, and once we are here in this section, what we're going to want to do is open up our terminal. So I know that some people are meeting us from breakout rooms, so I will go ahead and close my terminal here, and we will open up our terminal once more. So once more, we are going to type in Ubuntu. You will see an Ubuntu application. We'll click there. And that brings us to this terminal here. If you are on Mac or Linux, just go ahead and also search, but you would be searching for terminal. Okay. So I'm going to go ahead and make this a little bit larger just so that we can all see here. All right, so let's go ahead and copy this command here and paste that into our terminal. We're going to run that. And what's happening here is we are installing a GitHub repo. So we will get into the details of GitHub in our next and final session, which would be version control with GitHub. But for now, we are installing this repo to get our Conda environment set up. Okay, so once you guys are able to successfully run this command, go ahead and give me a thumbs up.
Excuse me, if I can ask you something. I got an error when I tried to run the code. It says that GitHub permission denied for public key. You could not read from remote repository.
Okay, give me 1 second here while I check. Okay, so for those of you running into issues with the git clone command, I will go ahead and send an updated command within the chat here. So go ahead and give this a try. Okay, so it seems like that worked. Awesome.
That worked. Thank you very much indeed.
Perfect. All right, so let me get everything back up here. So we were under this section 3 of our computing environment preparation. So now that we've ran that command successfully, what we're going to do next is, number 1, make sure that we are in the correct location. So what I'll have you guys do is print working directory. So that's what PWD stands for. So let's go ahead and run that once more. It is PWD. You can see that here in my terminal. Let's run that command here, and you will see AG2PI _ introduction to scientific computing. So if this is what you see here, go ahead and give me a thumbs up. It means that you successfully cloned that repo and you are currently in that directory. Perfect. All right, so I see quite a few thumbs up here. Awesome. So now what we're going to do is, depending on your operating system, we are going to run an installation shell script. Okay, so this installation shell script is going to install Conda, and that will prepare us for the next few steps that we have in this workshop. Okay, so if you are using Ubuntu or Linux, any other Linux distribution, go ahead and run this command here. You'll notice it says, if you are using Linux or Windows WSL2, run this command. And if you are on Mac OS, go ahead and run the very last command here, okay? What this is going to do is install, once again, the Conda environment that we will be using for today. Now, when you do run this command, it will ask you for your password. This will be the same password that you set up as you were installing your Windows subsystem for Linux. And if you are on Mac or Linux, it will just be your computer password that you would want to type into that space. So in order to paste into the terminal, you're going to want to click here within the README. And then once you're on your terminal, you can then either right-click to paste that in, or you can do Control-Shift-V. Okay. So once more, you can right-click on your mouse within your terminal window, or you can run Control-Shift-V. Okay. So it seems like a few of you are running into permission denied. Okay, give me 1 second here. So if your password was input incorrectly, you will get an error. So just go ahead and make sure that you are typing in that password correctly. It is running sudo, so that might be a problem. And it seems like some people are running into problems with both the Mac installation and some with the Ubuntu. So just double check, make sure that the password that you entered is the password that corresponds to your computer, okay? So I'll give everyone a few minutes here. And for those of you that were running into problems with this installation shell script, go ahead and raise your hand and we will send you over to a breakout room. For those of you that were able to successfully run that installation shell script, go ahead and give me a thumbs up just to see if some of us were able to successfully run that. And if it's still installing, just go ahead and give me a thumbs up just to know that the installation is proceeding.
It has worked for me. I didn't get the permission denied, but I'm getting timeout when it tries to run repo.anaconda.conf. It's the third time it has connection timed out in here. I don't know if the problem is here or.
And you're saying that's
else.
with, okay. Interesting. So let's go ahead and send you over to a breakout room just to see what the problem is there. Has anyone else been able to successfully run this shell script? So go ahead and give me a thumbs up if you successfully ran it. Okay, and I do see two hands up. Do we need to put you guys in a breakout room? If you can type in the chat what types of problems you guys are running into, that would be very helpful just to know where that help needs to be sent. Problem. Here's some
Okay, hi, Caitlin. I see your hand is up, and there's people in the breakout room helping other people. So you're getting an error, permission denied. That's right?
Yes, that's correct.
Okay, and you're comfortable talking to me here. Is that okay?
Yeah, that's fine.
Okay. So I guess one of the things I would do to start troubleshooting this is I'm not a Macintosh person, but or Apple, but I guess I'd open that file and see, can you run the first command on the command line?
Let's see. So
So if
within this,
I can put a link to what I'm looking at in the chat.
please, yeah, because I just have a link to the .sh file.
Okay. So if you open that up.
Oh, perfect. Okay, yeah, let's see what
And you look
we
at
get.
line number 2, and if other people are having the permission denied, they can follow along.
Okay. Okay, it
It's
says checking for sudo access, which may request your password. Okay, so I work for the USDA and we have some interesting permissions. So that might be part of my problem because it says I need to be an administrator to get sudo access.
Okay.
So that might be my issue.
I think I don't know how to circumvent that.
Yeah, I have to go to IT and get the special administrator password, but
Okay.
thank you.
All right. Sarah, do you know if you have Conda or Python already installed on your computer?
I do not know.
Okay. All right. I think I'm out of ideas.
Yep, that's fine.
Okay.
Thank you though.
Yep.
I can work on getting Python installed.
Okay. And then I see Jing, you have your hand up if you're willing. Yeah. Are you having the permission denied problem? I'm looking at it. Okay. And are you using a Macintosh?
No, Windows.
Okay. So I guess so, Emmanuel, I don't know what the Windows people are doing. I see an Ubuntu install that shell, right? That's what the Windows people are running.
That's correct. Yep. So let me go ahead and bring my screen back up here. Okay, so here we are under session 2. Let me scroll back down. So if you are running into any problems, you mentioned you're running Windows, is that correct?
Yes.
Okay, and you are running this Ubuntu install?
Right.
Okay, perfect. And what is the error that you are seeing on your screen?
Permission denied.
Permission denied, okay. And did it ask you for a password?
No, it did not.
Okay. So what I would recommend is that you close down your terminal. So we would just close that down. We would go ahead and then open up our Ubuntu once more.
Yeah, I tried that. You mean
Okay, and
close it and come back and try to enter again?
so for those of you that are running into problems, let's go ahead and troubleshoot this together. Can everyone see my screen here? All right, so what we're going to want to do then is rather than running the commands that we have here, again, this is going to be dependent on whether you're using Mac, we're going to want to run this file. If you're running Linux, we're going to run this. Okay, so let's try bash and then the name of the file. Okay, so if you're on Mac, it would be this command here, which I will post in the chat. And if you're running,
do I need to enter the folder first, a specific folder?
Yep, so we would want to change directory into prep. So I'm gonna go ahead and send that in the chat as well. So first we would change directory into session 2, prep, and that's what CD stands for. So we are changing directory into this folder. Once we do, we can run pwd to confirm that we are within that folder. And then once we're here, we should see those 2 files that we were trying to run previously. Okay, so if you guys are currently there, go ahead and give me a thumbs up. If you have changed directory into that location, give me a thumbs up. Okay, so once we are in this directory, we would then run bash, and then if you are on Ubuntu, go ahead and run that one. If you are on Mac, make sure you run the Mac one. Okay, so once you do that, it'll ask you for your password. So let me go ahead and send this in the chat. Okay, so after you type your password in, it'll continue with the installation. Okay, so let me know if those 2 commands that I just sent out are working for you. Once more, make sure that you run that updated command, which was bash space, and then the name of the file. If you're using Linux, you would type in Ubuntu. If you're using Mac, you would use the Mac installation. And you should see something print out like this. So this is what we commonly see in the command line. So let me make this slightly larger. So what's happening here is it's actually updating all of the files that come along with Linux. Okay, so this is similar to going to Windows Update, checking for updates. Okay, and if you are on Mac, it'll look slightly similar, but it's going to be installing something known as brew. Okay, this is important to be able to install the packages that we're going to be installing in just a few moments. So if you see something like this on your terminal, go ahead and give me a thumbs up, letting me know that you were asked for your password, you typed your password in, and now you can continue. If you are in an environment that has any form of security, like for example, governmental facilities, this will likely fail because we are having to use Sudo. So keep that in mind. However, if that is the case, you can still follow along. And if you choose to continue with this workshop at a later time, you can come back to this location and we will go ahead and get these changes made so that you don't run into this problem. Okay, so I did see the people that were raising their hand before give me a thumbs up. So it seems like we were able to successfully complete this step, but just as a final check, everyone give me a thumbs up if you guys were able to successfully run these installations. Okay, perfect. So I do see some thumbs up. Awesome. So now that we were able to get through that error, we are going to now hand it over to Nathan, who's going to actually teach us how to use Conda and then also how to use the command line. Okay.
Hello, everybody. So I'm assuming people have terminals open where they can see their shell. If you have that, keep them open because we're going to start to use them in a minute. I'm going to share my screen here. So we've been talking about the command line. First of all, my name is Nathan. I'm a postdoc at the University of Arizona. My background is in astronomy, but I work in the plant sciences department now doing data science. I started out using Macintoshes, which use the GUI environments for moving files and accessing programs and things. And Emmanuel talked about how there's the 2 different paradigms for accessing files and launching commands: GUI, graphical interfaces, and command line. And so the command line can be kind of intimidating but it shouldn't be. And what I'm going to try and do is get you to be able to use the basic commands to move things around and look at things and feel comfortable navigating the command line. Sometimes it's referred to as a shell or bash or terminal, so don't let that confuse you. The main purpose for the command line is to read commands, run programs. So bash is a certain type of shell, and that's the one you find most commonly on different systems. Either the one you just installed is bash, but if you log into HPCs or other servers, that's usually what you find. But sometimes there's other ones such as C shell or T shell or fish shell. So typical problems people have where they want to use a command line is you'll need to navigate to a file or find a file, create directories to put files in, check the length of files, see how much disk space you have, run one command, run several commands where the output of one command goes into the next command. That's called chaining commands. Running shell scripts, etc. So one thing that's important to understand is sort of how files and directories are represented on the command line. You don't have icons. Instead, you have these strings. And so I have 3 different ones here that I'm showing. On Unix, you get these slash and then some sort of text and another slash and then text. And maybe you're familiar with this, but this represents a file or a directory that's inside the home directory, right? So if you look at the last one with Windows, Bill is inside users is inside the C:, which is how they refer to a hard drive. So if you look at this image at the top, you can kind of see that you have the first slash is your root directory. Inside that, you have things. They can be files or directories, and they have a name. That's what this is. And then if you have another slash, you're at the next level here, right? And this is either a file or directory inside the home directory. So in order to interact with files and directories, you need to know a couple commands. So I'm going to open up a shell at this point. And the first thing I see, I'm going to make it a little bigger. I'm going to actually float it so that we can look at this. First thing I see is a prompt. There's information on my prompt, but this $ and this blinking is letting me know that it's waiting for me to type something in. Often you'll see this on a prompt. This is my username. I'm at Triploid, which is the name of the machine that I'm logged into. And then, sorry about that. And then this is the directory that I'm in. And then I have additional information. People can customize their prompt so that it shows you more information. In this case, this is base. This is my Conda environment that's currently active. So we'll talk about that later. So I can do an ls, and that's going to show, that stands for list. That's going to show me what files are in here, and they're in alphabetical order. I'm going to move into the AG2PI directory that I think you guys are already in. I use that using CD, which is the change directory, and I happen to put it in a couple directories deep. So work repos and then AG2PI Introduction to Scientific Computing, which you guys, I believe, have used get command, right, to pull that down, and you change into that directory. So now, make this a little smaller so we can see. I'm in this directory, and if I do pwd, which is path to working directory, it will show me the full path to where I am, right? There's a home, equent, work, repos, and then this directory. And I want to see what's in it. Again, I'll do ls, right? Now it shows me these are the 4 things that are in this directory. If I want a little bit more information about them, I can use arguments. So a lot of commands allow you to pass arguments to them. And one of the most useful ones is help, right? So it can, often it's either -- help or just -h. Sometimes one works, sometimes the other, sometimes they both work. So if we look at this, it prints out some help, right, for the command ls. And these things are usually a kind of a nightmare to parse visually, but there's information in here that tells you what all these different arguments do. One that's going to be useful to us is this -f. And what it does is it appends an indicator. So if we just look at it, the indicator tells us what kind of files these are. So if they end in a slash, they're a directory. And if they don't, they're a file. There's a couple other things that they can have after them. One is an @ symbol, which I believe means it's a link. Like it's not an actual file, it links to a different file. It's not too terribly important, but that's something you might see. One of the things that I want to do with this session, and I'm going to try and keep it quick in order to not cut into the next speaker's time, which is going to get into more scientific computing, which I think people are really interested in. But one of the things I want to do is I don't want to flood you with a ton of information, but I have a hard time imagining something that I've never seen before. If I show you a bunch of things that you've never seen before here within the command system, you might then sort of know what's possible, right? All of this stuff is easy to find if you use Google looking for help. So sorry if this is coming a little fast, but I'm going to go ahead and change directory into session 2 to ls again. This shows me the files that are in there. I'm going to go into command line fun, right? Because that's kind of that's the part of this workshop we're in. So again, with the arguments, lf is going to add stuff to these. There's no directories in here, so there's no slashes after these. There's another command or argument that you might want to use, which is -l. This is like a list, and then you get the long output. What this does is now each file within the directory is on its own line. This is each of the file names. It tells you the last time it was modified, the date that it was modified, and how big it is, and the permissions on the file. So usually you don't need to see a lot of this stuff. The file size is in bytes. I don't find that particularly useful. So another argument you can add after the L, you can tag on more than one argument. I'm going to do H, that's for human readable. Again, you start to learn these things if you can't remember them. You can use the help. So I'm gonna hit enter. Now it shows that this is 95K. If it was in gigs or megabytes, it would be an M or a G. These are just in bytes, so it's 237 bytes. So let's see where we want to go next. So we talked about command arguments. The A is useful. Sometimes there's a file in there, but it's not showing it to you. That's because any files that start with a period are hidden from you unless you specifically ask to see them, and that's what the A does. So here it's now showing us that there's 2 directories in here, a dot directory and a dot directory. So I think this is the next thing. Nope, did that. Yeah, so getting around again. So there are, I had to make these side by side. Okay, so there are 4 special directories and they have special symbols, right? So dot is always the directory back. So if we were to look at this path we're in using PWD for path to working directory, this is where I am. Home, equent work, repos, the AG2PI session 2 command line fun, right? This is the directory I'm in is command line fun. If I want to look at what's in session 2, that's 1 directory back, I use the dot. Now that's showing me not what's in the current directory, but what's in the session 2 directory. And you can see the command line fun is in it, right? Because we just looked back a directory. And dot is the directory you're in. So I can do ls and see what's in the current directory. I could do ls dot. It's the same thing. It's just a dot is just explicitly stating the current directory that you're in. And that can be useful in different situations. And then the tilde is used as your home directory. So if I do cd tilde now, I'm in my home directory where I'm just in home equent, right? So I kind of go back to my base camp home directory. And last, the other useful special shortcut is the -hyphen or the dash, which just means go back. What is the last directory you're in? So I was in the command line fun directory, then I moved to my home directory. Now if I do cd dash, I'll just go back to the command line fun. So you can sort of bounce back and forth, right? From one directory and back using the dash. Does anybody have any questions at this point? I actually can't see any. I can't see all the people. But Emmanuel, do you see any hands up or no? Okay.
No, I do not. Just double check. Nope, we are good.
All right. So I want to probably wrap up in the next 4 minutes. So I might, so that Arian has enough time. So I might need to get to the Conda stuff. Here's a bunch of different commands that are useful to know. So if people want to look at those, but obviously, like, you're going to want to be able to, beyond listing the contents of a file, you want to be able to make a directory. So let's make mkdirf or make directory. We'll make one. So I can make test directory. Now there it is. ls-f shows that slash after it, so it is a directory. Say I wanted to make a whole lot, like I can do -p, which means it will make all of the directories. If I would make a string, like say I wanted to do 1, 2, 3, 4, right, a whole bunch of directories inside directories. So now that's happened. So if I go into the directory called 1 and I look, now there's 2, and I can go into that. There's 3. So it made all of them. So if I go back into that first directory 1, I can use this command called tree, which gives me a bit of a visual output of what's going on, right? So dot is the directory I'm currently in, and then there's a directory 2, 3, 4. So if I was to go back, right, by doing cd ... into the command line fun directory, I can do tree there. Now I can see that in the command line fun directory, there's this shell file, there's this shell file, there's all of these directories inside each other that I just made. There's this text file, and there's this test directory that I made. So I'm going to remove that test directory, and I can do that using rmdir, and that's useful because it will only remove an empty directory. So I made test directory, it was empty, so now it removed it. But if I want to remove the 1 directory, it's going to complain that it's not empty, right? So you can then do rm-r recursive 1, right? And now it's deleted everything. But so rm is how you delete files or directories. But this is something people should be a little bit careful with, because on the command line, there's no trash, right? You don't get an undo when you delete things on the command line. There's no trash that you can go look at and pull something out if you made a mistake. So it's always good to really think about it. If you want to look at the contents of a file, there's 2 different ways that I commonly do it. One is less. So we see popl vu there, which is a text file. I can tab, another thing that's useful to know about is tab completion. So I look and I see the popl vu is in there, I can type less, and then I can just start typing popl vu and hit tab, right? I've typed pop, I hit tab, now it's completed. Now I can look at it. Now I can read the popl vu using arrow keys. So less is a command that lets you sort of read text files or read files. The other way to do it would be to do cat, which is, I think you guys could go back to catalog, but you can cat popl vu. And so instead of like it bringing up a program where you can use the arrows to go up and down, it'll just spit it all out. So just spit it all out. And now we see the very end of it, which can be useful for small files. So if I want to see what's in conda.sh, I can just do cat conda.sh, and there it is. Okay, so speaking of conda.sh, conda is an environment where, I'm going to go ahead and close my, get rid of this. So conda is an environment that allows you to have specific Python environments for different tasks. And this is important because some programs you run might want to use a different version of Python or a different version of libraries, or some libraries might be incompatible. You can't have them both installed at the same time. So when you start a project, you might want to create a new conda environment for it. And then within that conda environment, it installs a particular version of Python and all of the different libraries that you request. So if people are with their terminal and want to type along, you can look at this file conda.sh, which is in the AG2PI Introduction to Scientific Computing repo, session 2, command line fun. You can find this conda.sh. Now you can just run it if you want, and it'll do everything we need to get you ready for Arian. To do that, I would do dot and then dot/conda, right? That's one way to run a shell script. You use this dot, which means your bash is going to execute it if you do dot space, and then just the name of the file, which I told you is dot/conda. That's just sort of a habit of mine. You don't have to do the dot slash. You can just do dot and then the conda.sh, right? And it should run. I'm going to go through it step by step so you kind of see what's going on. First, I have conda installed. I'm going to do conda, and I'm going to create a new sorry, just answering somebody's question in the chat about how to get out of, I'm assuming less, but so conda create, so I'm going to create a new conda environment, and I'm going to name it -n, and I'm going to call it ASEM's Workshop, right? So I hit enter, and oh, it already exists because I already created it. Yes, I'm going to just remove it. Okay, so it says it's going to create it. It wants to make sure that I'm cool with it. This is where it's going to put it. That's just the default. I can hit enter here because the Y has got the brackets around it. I could be explicit and just type Y and hit enter. But because the Y has the bracket around it, I know if I hit enter, it's the same as entering yes. And there we go. So it's created it. And now it says to activate this environment, use conda activate ASEM's Workshop. To deactivate it, do conda deactivate. So if you see here, I'm in the base, my base conda environment. So I'm going to switch over to the ASEM's Workshop by typing conda activate ASEM's Workshop, hitting enter. Now here I am. And you may not, you probably won't see this, right? Because I have a prompt where I've installed a special prompt, right, that tells me where I am. But if you want to know for sure, if you're in the ASEM's Workshop conda environment, you can do conda env for environment list. Now, it shows me all of the environments that I have, and this is going to give you an idea of why we use these, right? I have one for OpenCV as a Python library, and it has different, it's being actively developed. So 0.13 has certain functions that 0.14 doesn't have anymore. They changed the names. And so if I developed some Python script using OpenCV 0.13, and then I upgrade to 0.14, that old script might not work anymore. So I have a conda environment just for that. So I know if this script was developed using 0.13, I can do conda activate, right, this environment, and then I'll be in that environment and those old scripts will work. This asterisk here is showing me that I am in the ASEM's Workshop environment. So that's good. All right, so I'm going to go ahead and I'm going to do an ls to see what's in this directory again. We were looking at the conda.sh, so I'm going to do cat conda.sh. Now I'm going to do the next step. So we did conda created the workshop, and then we did conda activate ASEM's Workshop. So if I do conda info, it's going to show me some information about my current environment. That is that it's the ASEM's Workshop, and it shows me the Python version is 3.8.3 final.0. That's not the Python version that this environment is going to use. It's a little confusing. This is the Python version that conda is using to do its work. But if I do conda list, I can see everything that's in this is in this environment, all the packages that are in it, right? And right now it doesn't have any. So I'm going to install some. So looking again at this conda.sh, I see this command conda install. I'm going to install matplotlib, scipy, scikit-learn, and pandas. So I'm going to copy that, right? Conda install. And if you want to do it with me, you can. In fact, you need to do these things for the next part. So you could just run the script or do them one by one. So I hit enter. And it's going to show me all of the things it's going to install. It's installing more than I asked because each of those things has its own requirements. I'm going to say yes, proceed. It's doing its stuff. It's done. Now, if I do conda list, it'll show me everything that's in here. And in particular, it shows me that Python version is 3.9.12. That's the version when I run stuff, my own scripts in conda, that's what's going to be used. I can see that it installed NumPy, even though I didn't explicitly ask for it. That's a requirement of many, many things, right? So it went ahead and installed it. If I wanted to see if there's a certain library installed in here, I could use grep, which is a program that searches through text. So I could do conda list, right, which just creates this, spits all that out. But instead of having it spit out to the terminal, I'm going to use a pipe, and I'm going to pipe that into grep. Now I'm going to tell grep what I want to look for, which is, let's say, matplotlib. Make sure I installed that. And there it is. So I took the output of a conda list, and I sent it to this program that is going to search for matplotlib, and then it just spits out any lines that have matplotlib. And there it is. So I think that's about it. I need to give Arian the rest of the time, I think. Are there any questions? I know that was a little bit fast. I was trying to make up for some lost time.
It looks like you got one question. What was the install command run?
What was the install command run? You mean to run the, let's see, who asked that? Jerome, if you're comfortable unmuting yourself, you can. The last thing you install.
Yeah, just the last thing you installed, I didn't quite catch. Are we what you installed in the last step?
So the last thing I did was in this conda dot. Can you see my screen? No.
Yeah, no, I created the environment, but I didn't see what you installed.
Okay, so if you look at the conda.sh file in the command line fun directory, do you have that?
Yes.
Okay, so just look at the last line of that. Is that what you're asking about, the conda install?
Oh, you just installed that sh bash. Wait, what was the command?
Here, I'll post it into the chat. This was the last thing I ran.
Okay,
So,
that one. Yes.
Yeah,
okay.
so that just installs the Python modules so that they're available to you in this environment, right? If you leave this environment, they may not be there, right? Because that's the whole point of the environment. They exist.
Yeah, I had followed all along and I just missed
Okay.
that last command.
Okay.
It's installed now.
All right, great. Okay, well, are there any other questions? I don't see any. All right, I think Arian's next, right?
Travis is going to cover something before.
Okay.
Hey, Fred, if you want to move over to the support room, I think we can get you taken care of with the conda issue. Unless, Nathan, do you have a quick fix for that?
I have to look. I'll go in the support room.
Sweet, sounds good. All right, everyone. Well, I hope you guys have had some success today in getting everything set up. Now I'm going to be talking about writing scripts and why those are important. So, let me get my stuff set up here. All right. Can y'all see my screen okay? Can I get some thumbs up if you're able to? Sweet, all right. So from this point, so far we've been working in notebooks whenever we want to do any kind of analysis or anything like that. But now that we're moving to the command line, we're able to run scripts standalone without notebooks. So those are important because you can, like Emmanuel mentioned at the beginning, you can automate tasks, you can run very complex batch tests and batch scripts, and as well as it helps with reproducibility of your science because you're not going to be editing a notebook every time you want to do something different with that script. So we're going to first write our first Python script, and then we're going to talk about how to use arguments in order to make scripts more robust. So if everyone could navigate to session 2 from the command line. And then if you could navigate to the scripts section, so CD scripts section. So right now I'm in my working directory of the scripts section. You can see 4 files here that we're going to be using today. Let's see if I can get a thumbs up if you guys are able to get over there. Let's see. Is everyone able to get to that? Okay, sweet. I see a few. Okay. So we're going to now run the command CODE, code, and then dot. Anytime you see that dot, it just means here. So we're wanting to code here. So this should open up our VS Code, which I hope everyone was able to install successfully. Okay, was everyone able to open VS Code? I'm going to be asking for a lot of thumbs up throughout this, so I don't leave everyone behind. Command code not found. Okay.
It was code space dot, right? Yeah, it didn't find it. I can open, I don't know why it didn't open from within the environment. I could open it outside the environment probably and link it.
Yeah, if you wanted to try that and then just navigating to the script section manually. So what you're saying is going to just opening Visual Studio Code and then heading there manually through your file explorer.
Through the remote, yeah.
All right. Sounds good. So what we're going to do now is to create our first Python script. Very exciting. So we're going to go up to the top left of VS Code, and you can see this little button right here. This is to create a new file. So we're going to click that. It's going to bring up this box, and this is us creating a new file. We're going to type HELLO, hello, underscore world.py. All right, so this is going to bring up a blank text document with the file extension .py, which means that this text document is designated as a Python script. All right, so just like those little cells we used in the notebooks last week, we can type code into this and then run it. But instead of running it just with Shift Enter or with a button, we're going to run it from the command line that you guys have been working with today. So we're going to type our first bit of Python code now. So we're going to type print and then open parentheses and type hello space world exclamation point. Then we're going to do Control S to save it. Was everyone able to create that and save it? I get a thumbs up. If you guys are having any problems, feel free to join the support room or to unmute yourselves and ask. All right. Well, again, if you guys are getting confused at all, this recording will be up and sent out to you. So we're going to now try to run this script. So if we open the terminal in VS Code by clicking this top left button right here that says terminal and say new terminal, we now have a terminal that is in this working directory that we were in. So if we do ls, we can see we have a new file that's the hello world.py. So let's try to run this script. And the way you run a script is by typing Python 3 space, and then you type the name of the script. So hello_world.py. So if we click enter, we see we get the printout hello world. That's awesome. You have just written your first Python script and ran it. Great job. Very exciting time. However, what if you wanted to run something else? If you wanted to run hello your name, so if I wanted to say hello Travis, I have to edit the script directly. And that's not very good for if we wanted to write an analysis tool. Let's say you wanted to run an ANOVA on some data, but you didn't, you want to do it multiple times on different data. You would write one script that runs an ANOVA, but you wouldn't want to go in there and edit it to change what data is loading every time, because that make the script prone to error, right? So what we're going to do is learn how to use a thing called arguments. So arguments are a way to get variables and information into your script from the command line. So let's take a look at that now. If you go over to the left side of your screen and type arguments using, click on arguments using argparse, we'll see a whole bunch of stuff. So this is what arguments look like. We're going to be using the import statement. We're going to use the package argparse in order to run our script and to use arguments. So what this is going to look like, I'm going to give you, don't feel like you have to run this, but what we're going to be able to do with this is to say something like Python 3 arguments using argparse. And then we'll do what's called a flag, which you do a dash and then a letter that you designate. We're going to do -n, and then we'll be able to say something like my name. And it'll take in whatever you put after that flag and use it in your script. So this is powerful for a number of reasons, but first let's talk about how to do it, and then we'll talk about why you should do it. So this is going to be boilerplate code, or code that you're going to add into every time you want to use arguments, this parser, argparse, argument parser. Then you're going to put some kind of description. And this description is fine. You can put whatever you want. And then you're going to use this form that I've included here to add as many arguments as you like in your scripts. So the first thing that goes inside this argument is a short flag. So -n, we're adding one argument here called name. So just where I ran it in this last command, I used -n to signify that I was giving it that argument. So that's where you specify that. Then this one that comes after it with 2 dashes is the long flag. And that is the name that you're going to use that argument in the script. So here I have this print statement, this print hello, and then args.name. So we have this name variable that we can use to access whatever we pass from the command line by using dot notation. So args.name. If I had to change this to name1, whenever I wanted to use it in my script, I would args.name_1. So that's the variable that you're going to use. And then you tell it what type of variable it is. So we're using a string variable right now. And then we have a help message. So anytime you are trying to run someone else's script and you're not sure what flags they're using, you can use the flag --help. And it'll give you a little printout that says, okay, well, this script can take two different flags, the -help flag, which we just used, and then a -n flag that uses that is the name that you want to show. And then it shows our help string right there that we gave it. So in this way, we can run our scripts using a dynamic variable from the command line. So I encourage you to try to run this script from the terminal, giving it your name. So I'm going to put Travis. And as you can see, it says, hello, Travis. So that's awesome. So hopefully some of you were able to run that. Good deal. So what's some reasons why you would use this? Well, last week we talked about reading in a CSV in order to do analysis on it, that tabular data, comma separated value list that we see in Excel. If we go to read._csv.py, this is another Python script that I've prepared that takes one argument, as you can see here with the -c flag. And what it does, it reads in the CSV. You'll notice this is from the notebook we did last week, where we're reading in a CSV, which is just a path to that file. And then we're going to print out the first few rows of it using df.head. So I've included a CSV, an example CSV. And if you click right here, you can take a look at it. As you can see, it's just some water quality data that I collected. And we're going to load this in and display the first few rows. But of course, you might want to do some sort of analysis on this. So let's go back. I'm going to close these out. Then we're going to read.csv. All right. Let's do Python 3 read_csv. Python 3 read_csv. And like I said, it's going to take one argument, which is the -c flag. I'm going to do -c, and then it's going to take the path to a CSV. So we're going to do, we know this example CSV is in the same directory we're in. So we're going to say here inside this directory, that's what that // means, look for example.csv. So we're going to run that now. As you can see, it read it in, and then it's displayed the first few rows. And I'm not going to go through the next one, but just to show you what you're able to do, you are able to do a ton of different arguments at the same time. So this script has two arguments, the -x and -y flag. And it will be able to create a matrix, which is another thing we did last week in the notebook. So it takes two arguments, like I said, the -x and -y, and it's going to use that right here, args.xsize, args.ysize, in order to make a matrix that's full of ones. So let's try to run that now. If we ls, we can see that we do have that create matrix.py in our directory. So let's do Python 3 create matrix. And if you hit tab, you can do that tab complete. Then do -x, and we can give it an x dimension of, let's say, 4. Then we can do -y to give it a y dimension, and say and we'll do 5. So this will create a 4x5 matrix in our script. And then hit enter. All right. So there is another way to use scripts, and hopefully now you see that you can use these to make dynamic analysis scripts where you read in CSVs and do some kind of analysis. And yeah, so that is the end of my section. So I think I'm going to hand it back to, let's see, is Emmanuel back from the breakout rooms?
No, I guess he's still in the breakout room.
All right. Well, we are actually running a little low on time, but however, we made a bunch of progress getting everyone set up for next week. We had planned on Arian coming back here and working on some machine learning code with you guys in another notebook. But like I said, we are out of time. So I think we'll use the rest of the time, and as long as you guys would like to stay, to solve the remaining issues. And then maybe everyone can show up next week and get started on the same footing. So I think that's probably what we'll do with the remaining time we have, about 8 minutes. And then we can also stay a little bit longer if anyone has time. So thank you guys again for being here and showing up to these workshop series. Again, next week, we're going to be doing we'll be doing the machine learning from this week, as well as some version control with Git, which will take these scripts that I just wrote and we'll learn how to upload them onto your personal GitHub and work collaboratively with your team members in order to do version control on those scripts. So at this time, do you guys have any questions that we can work through or anything like that? Again, I thank you guys so much for coming.